If you have observed antenna systems on a PCB, you may have seen components like these type of stubs and lumped elements consisting of inductors and capacitors connected in between the antennas and the source. These components or these circuits are known as the matching network. So in this video, we are going to see what is the importance of these matching network and which are the categories of that. So if you consider a system which consisting of the load and which is connected to the source through the transmission line having the characteristic impedance of Z0. If there is an impedance mismatch between the load and this transmission line, that is, if the ZL and Z0 are not equal, there will be some reflections happening in between them. That means that if there is a wave coming from the source and going to the load due to the impedance mismatch between the characteristics impedance of the transmission line and the load, some part of the wave will be reflected back. So which is given by this expression tau is equal to ZL minus Z0 by ZL plus Z0. So it is very important to have Z0 and ZL to be equal. If this is not happening, there will be impedance mismatches and will cause the reflection. So the impedance match is very required for the maximum power transfer, and it is very important to avoid the reflections, and it is very important to have the impedance match to get the better efficiency. Otherwise, it will cause the heating and the wasted power. So let's assume the case like if we have designed an antenna and its impedance. So if we are considering a system, we know that usually the characteristic impedance of the transmission line is 50 ohm. And if we are going to design an antenna, like if we are designed an antenna, but the input impedance is not 50 ohm, but you have designed an antenna in such a way that all other characteristics like bandwidth and gain, all the radiation pattern, all other requirements are satisfied for this antenna. But only thing is the input is not matched to the 50 ohm. So in that case, it is not always required to redesign the antenna to have the impedance equal to 50 ohm. So in that case, what we can do? In that case, we can use an impedance matching network in between the transmission line and the load. So because of this impedance matching network, the total input impedance of this load, that is our antenna and the impedance matching network, will be become equal to the characteristic impedance of the transmission line. That means Zdin, the total impedance of the whole system, will become equal to the characteristic impedance, and it can avoid the reflections and can cause the maximum power transfer. So these type of components are known as the matching network, which are used to match the impedance of the designed antenna to that of the source or the transmission line, which is used to connect the source to the antenna. So I have taken this picture from this website check.com. So some of the important matching networks are quarter wave transformer. This is mainly used for single frequency matching if the antenna impedance is purely resistive. Next one is step matching. It can be single step matching, double step matching, etc. And another one is using the lumped elements like inductors and capacitors. They can be pi network, that is the components will be as aligned in the shape of the pi, and this is mainly used if we require more bandwidth matching. And it can also be like T network, or it can be in form of L network. T network is mainly used For high Q matching, L network usually consisting of two components like these things, one in shunt and one in series configuration. So these are the main impedance matching circuits that can be used. So if you have to design these impedance matching circuit, we usually use Smith chart to find out how we can match the load impedance, because we may be having some impedance equal to ZL, and we can use the Smith chart to find out how we can match this load impedance to the matched impedance, that is 50 ohm impedance. So in our upcoming videos, we can see how we can use the Smith chart to design these type of matching networks. So I hope you get some idea about what is mean by these matching networks and what are its importance. Thank you.